In this video, we're going to be solving quadratics using square roots. In order to do that, we need to understand a few concepts. First, we need to understand the relationship between squares and square roots. They are, in fact, inverse operations of each other, which means that they cancel or undo each other. So the inverse of a square is a square root. The inverse of a square root is a square. And squares are just fancy ways of saying something raised to the power of 2. Let's talk about what a quadratic is. A quadratic can be an equation or an expression where the leading term has a power of 2. So let's take a look at some visuals. What does that mean? So in the following, we have some examples. Which of the following are quadratics? Well, the first example, the leading term is the variable x, and that's just being raised to the first power. So that's not being raised to a power of 2. That's not a quadratic. This is actually a linear equation. But example B here is a quadratic, and it's actually a quadratic equation because it's a quadratic with an equal sign. And the leading term here is x squared. We talk about leading terms in terms of their powers. So whatever has the highest power is always a leading term, regardless of what order it starts in. This one was given to us in order of degrees. So it's just a quadratic equation. It's got a term with a square. Example C here is actually a quadratic, but it's just a quadratic expression because it doesn't have an equal sign. And even though this term 2x squared is not in front, we could reorganize it and write it in terms of leading degrees, and then we could rewrite it as 2x squared plus 3x. So sometimes you're given equations or expressions out of order, and you always have to think in terms of the highest degree. That's always your leading term. Another thing we might need to understand is the difference between simplifying a square root or solving a quadratic equation. When we simplify a square root, we get one solution. It's always just the positive root. However, when we solve a quadratic equation, we actually get 2 solutions sometimes. So if I undo the x squared by square rooting both sides, then we get x. But the square root of 36 is actually 2 solutions. It's positive and negative 6. And we can check that by substituting our solutions back in. If I square positive 6, I have 6 times 6, that's 36. But also if I square negative 6 times negative 6 is also positive 36. So there are indeed 2 solutions to a quadratic. Up to 2 solutions. I don't want to say every time. As you go farther in math, you may figure out which quadratics have 2 solutions, which have 1, or which have 0 solutions. All right, let's use square roots to solve quadratic equations. Here's some tips. We always want to get the variable by itself. So in this example, we're going to be getting the squared variable by itself. And then to undo that, we're going to square root both sides. Also, we're going to practice, if we get an irrational solution, we're going to leave our answer in radical form. So in some upcoming videos, we're going to be solving Pythagorean theorem problems, and we're going to see equations that look very similar to this. So we got to be able to solve them. PEMDAS says that we need to simplify exponents before we do anything like addition or subtraction. So I'm going to square 3 and get 9. I'm going to square 4 and get 16. Now I can combine those and get 25. Now I have x squared by itself equals a number. We can undo that square by square rooting both sides. And remember that we get 2 solutions, positive and negative 5. Let's do another one over here. Again, we're going to simplify our exponents first. So 3 squared is 9, 4 squared is 16. I'm going to get x squared by itself on this side by subtracting 9 from both sides. So 16 minus 9 is 7. I want to get rid of the square now. Square root both sides. And we can't simplify the square root of 7, but we need to make sure and say that we have 2 solutions, positive square root of 7 and negative square root of 7. Let's do another example. Same process. So 2 squared is 4, 4 squared is 16. Let's get that x squared by itself. We'll subtract 4 from both sides. So now we have x squared equals 12. We can undo the square by square rooting both sides. And in this case, we have an irrational radical here. The square root of 12 is irrational, but we can simplify it. 12 is the same as 4 times 3, and we can take out the square root of 4. So there's a 2 at the front. The 3 stayed behind under the radical. And let's make sure and say that we have two solutions, positive and negative 2 times the square root of 3. Let's do another example. In this case, to get x squared by itself, we're actually going to divide or get rid of this multiplication of 2. So dividing both sides by 2 gives me x squared equals 9. And then we can square root both sides, and we get x is positive and negative 3. Let's get a little fancier here with our terms. A couple more examples. Again, I'm going to simplify 5 squared first, and then I'm going to simplify 5 times the square root of 2 squared. So this is a binomial squared. I need to make sure and square each of my numbers in this binomial. So 5 squared is 25, and the square root of 2 is, the square root of 2 squared is 2. So 25 times 2 is 50. So now we can get x squared by itself, subtract 25 from both sides. That leaves x squared equals 25. Square root both sides to undo that square, and we get x is positive and negative 5. One more example. Again, let's square this binomial. We're going to square 3. 3 squared is 9. The square root of 2 squared is 2, so 9 times 2 is 18. 9 squared is 81. Let's get x squared by itself and subtract 18 from both sides. So x squared equals 63. And again, 63, if I want to square root it, is an irrational number, but we can simplify it. We can break 63 up into the factors 9 times 7 and take out the square root of 9, which leaves a 3 at the front. And we left that 7 behind under the radical. And then make sure that we say two solutions, positive and negative, 3 times the square root of 7. And with all of these equations, you can substitute your solution back into the problem and make sure that your left side equals the right side of the equation. One more thing we can talk about. Here's where the fancy term square comes from. Because if we have a square, the actual shape, to find its area, we multiply the length times the width, and in a square, they're the same exact thing. So s times s is s squared. So that's kind of where the term square comes from. We can use this process to actually find side lengths of squares if we know the area. So if we know that the area of the square is 25 square feet, we can find the length of the side. We know that the area is s squared. If we set that equal to 25 and square root both sides, we can find our solution. Now in this case, even though we have two solutions, positive and negative 5, we need to think about a real-life application. There is no such thing as negative lengths or negative distances, so we only care about the positive solution 5. So the side length of this square is 5 feet. One more time, we can do the same thing. This time we know the area is 20 square feet. So if I set s squared equal to 20 and square root both sides, we can find the side length of the square. In this case, it's an irrational side length, but we can simplify it and keep it in radical form. To simplify the square root of 20, we're going to factor it into 4 times 5 and take out the square root of 4. So we have a solution 2 times the square root of 5. And we could think about what that's approximately. We could round decimals, all kinds of ways that we could think about it, but it's approximately 4.5 feet. This is the most accurate value, though, right here.